Hello, welcome to MacKay's biology class. We are today working on Hardy-Weinberg practice problems. These are the 4 problems that you hopefully have tried to solve already, and I'm going to run through all 4 of them. Question number 1. 9% of an African population is born with a severe form of sickle cell anemia, little less, little less. That tells us the content that the question is giving us. Little less means it's the homozygous recessive phenotype, or in Hardy-Weinberg symbols, it's the Q squared value. Q squared value in this question 9%. We always change that into a decimal, so 0.09. What percentage of the population will be more resistant to malaria because they're heterozygous? So what we're looking for is the 2PQ. That's what we're trying to solve based on what the question gave us. So if we know that Q squared is 0.09, we can do the square root of Q squared to figure out Q, and Q is 0.3. Once we know Q, we can use the formula P plus Q equals 1. If we know that Q is 0.3, hopefully you can do this in your head, tells us that P must be 0.7. Once we know P plus Q, we can solve for 2PQ. 2 times 0.7 times 0.3, run that through your calculator, or even do it in your head, 0.42, or it asks for it as a percentage. 42% is the correct answer for question number 1. Question number 2. Let's say the brown fur coloring is dominant to gray fur coloring in mice. If you have 168 brown mice in a population of 200, what's the number of homozygous dominant, heterozygous, homozygous recessive? So we're looking for the P squared and the 2PQ and the Q squared. Now what we know is that both of those top 2 categories, the mice are brown. And in this category, the mice are white. We have to start with the one that we know for sure. We have 168 brown mice. We don't know of that 168 how many of them are fit here and how many of them fit there. There's no way to break that down just from the question. But we do know there's 168 brown mice. That means there's 32 white mice. And the only ones that are white are the homozygous recessives, or the Q squared. That has to be your starting point. Q squared is 32 out of 200. Almost always you're going to start with a homozygous recessive phenotype, if that's what the question's given you, because that's the only one you know for sure. So Q squared is 32 out of 200. Calculator tells me that that equals 0.16. And now we're off and running. From that, we can figure out Q. Take the square root of 0.16, you get 0.4. P plus Q equals 1. That means P must be 0.6. And now we can just start solving. P squared for part A, homozygous dominant, is just 0.6 squared, otherwise known as, so we'll square that. Oh, sorry, I'll do it differently. P squared, 0.6 squared equals 0.36. That's our frequency, but there's 200 mice. Means that in total there is 72 that are homozygous dominant. 2PQ, that's a Q, 2 times 0.6 times 0.4 gives us 0.48. But again, there's 200 of them, which means out of the 200, 96 of them are 2PQ. So we've got 72 homozygous dominant. We've got 96 heterozygous. And we already had our 32 of the homozygous recessive. Always start with your homozygous recessive number. Next question. 98 of 200 individuals show the recessive phenotype. Question's telling us recessive and phenotype means we're starting with Q squared again. And our Q squared is 98 out of 200. Punch that in your calculator, 0.49. What percentage of the population would predict to be heterozygous? So again, we're looking for 2PQ here. We can figure out Q from Q squared, the square root of 0.49, 0.7. P plus Q equals 1 means P is 0.3. And punch it in the 2PQ. Figure that out, you get 0.42. It asks for it as a percentage, 42%. Last one. Population of butterflies, color brown, capital B is dominant, or the color B, that's color white, sorry, little b. 60% of all butterflies are brown. similar to the previous question, that means that of the brown ones, that's the 2 PQs plus the P squareds, which doesn't help us. We don't know of that 60% how many of them are heterozygous and how many of them are homozygous dominant. What we do know is that 40% are the Q squareds. Has to be that way. So Q squared equals 0.4. Again, now we know we can figure out Q, square root of 0.4, 0.632. It doesn't really matter for now how many decimals you keep going. Once we know Q, we subtract it from 1 to get P, 0.36754. And now we can start figuring things out. They want heterozygous here. That's the 2PQ. So we've got our Q, we've got our P, times it by 2, and we get 0.465, or 46.5%. The question would tell you certainly if they wanted it as a 1 decimal or rounded to the whole number, you'd always get that information. Next one, they want P squareds. We have our P right here. We square it to give us 0.135. And again, as a percentage, 13.5%. Maybe they asked it as a whole number, 14%, depending on what the question was asking for. It's different on different tests and different questions. Make sure you ask, or make sure you understand how many decimal points they want for your final answer. And that is it for the Hardy-Weinberg practice problems. Talk to you later. Bye.